Hello everyone, in today's video we will be reviewing what we've learned about fractions. Specifically, we will be talking about how to add and subtract like fractions. We will remember how to compare fractions, how to make equivalent fractions, and how to find the fraction of a number. So let's get started. First of all, how we add like fractions. A reminder of what like fractions are. Like fractions have the same denominator, so then the same number on the bottom. So let's say 3/4 plus 2/4, right? These two fractions both have 4 as the denominator. And if you remember what we have been saying since we've been learning fractions, that what you do to add two fractions like this that have the same denominator is you add or subtract, depending on if it's addition or subtraction, only the top numbers. The bottom number stays the same. So the bottom number is going to be fourths, definitely. And then for the top number, we say 3 and 2 makes 5. And if we were doing subtraction, so if we were doing, for example, 3/4 minus 2/4, again, the result would be fourths, right? And for the number on top, I'd say 3 minus 2 makes 1. So my result would be 1/4. Then the question arises, what do we do if there are fractions with different denominators? So let's say 2/3 and 4/5, right? Now we have talked about this before, but we're not going to go into this right now, about how we do this, how we solve additions and subtractions like this, where they have different denominators. But I just want to remind you that the procedure is different than this. It is much more complicated, and we don't just choose one of these two and say, okay, well, I choose 3, so it's going to be thirds, right? No, that's not how I do it. It's a complicated process. But we're not going to go into that right now. Right now, we just want to remember what we do when the fractions have the same number on the bottom, and that is we add or subtract only the numbers on top. Next, what do we do when we want to compare? So let's say, with comparison, there are two cases, right? There's a case where the same number is going to be on top, and then the other case is that the same number is going to be on the bottom. What do we do when there is no same number? Again, that is something we're not going to talk about right now. So, case number 1, the same number is on the bottom. So, say there's both of these fractions are fifths, right? This is 4/5, and this is 2/5. Okay? When the same number is on the bottom, and you might want to write this, when the same number is on the bottom, the greater fraction is the one with the greater number on top. So that would be the 4, because the 4 is greater than 2. So 4/5 is greater than 2/5. So again, if I have here, for example, let's say 5/6 and 1/6, 5, because the same number is on the bottom, then, and 5 is greater than 1, 5/6 is more than 1/6. But what if the same number is on top? So let's say we have 9. Both of these fractions have 9 on top. And then this fraction is tenths. whereas this fraction is 12ths. When the same number, and this is, again, you want to write this somewhere for the second case, right? When the same number is on top, and the greater fraction is the one with the smaller number on the bottom. And if you don't remember why, we say that that's because if we were imagining pizzas again, in this case we have 9, in both cases we have 9 pieces. But this pizza is cut in 10, whereas this pizza is cut in 12. So 9 pieces from this pizza are small, or less basically. It's less pizza overall than this one, right? Where there's 10 pieces, so the pieces are bigger basically, right? So greater again, when the same number is on top, the greater fraction is the one with a smaller number on the bottom. So this one. Next, another example. Let's say we have 8 here, right? They both have 8 for numerators. This one has 7ths. This one has 10ths. Since the same number is on top, the greater fraction will be the one with the smaller number on the bottom. So this one right here, 8/7. Right? 8/7 is greater than 8/10. All right, let's move on. Let's move on to equivalent fractions. Equivalent fractions, remember we have talked about this in the past, and what we said is going on is that, let's say we have a number like 3/4, right? What does that describe? That describes a pizza that was cut in 4 pieces, and we either have 3 of them or 3 of them are missing. This describes a part of the pizza, right? But then the question becomes, what if same pizza was cut into, let's say, 8 pieces, right? Or 12. How much pizza would there be then? What we need to do here is we need to think, okay, well, basically what we did here is we tripled the total number of pieces, right? Because 4 times 3 makes 12. Sorry, I was looking at it from the side a little bit. Right? 4 times 3 makes 12, right? But if I tripled the total number of pieces, that means that I also tripled the number of pieces I have, or don't have, depending on what this fraction describes. So that means that 3 times 3, I'm going to have 9 pieces now. So this is what happens here with equivalent fractions. It's figuring out what number do I have to multiply bottom number to get this, and then multiply this, the same number with the top number. So we are multiplying both the top and the bottom number with the same number, in this case 3, and we get a new fraction, but this fraction basically has the same value, equal value, equivalent, right? Equal value as this fraction, because it's the same amount of pizza. It's cut, and it's just cut into more pieces. So let's say, for example, that we have 5/9, right? And we're being asked, okay, well, what's the equivalent fraction to 5/9 with a numerator of, let's say, 40, right? Now what we need to do here is figure out, okay, I multiplied this 5 with something, and it became 40. What did I multiply 5 with to get 40? I multiplied 5 with 8, which means that I also need to multiply 9 with 8. And by doing 9 times 8, I'm going to get 72. So the equivalent fraction to 5/9 is 70 seconds, basically. Let's see. So here you saw an example where we knew the top number, we knew the numerator instead of the denominator. Another example is trying to figure out the reverse, right? So, for example, let's say I give you a fraction. This time I'm not giving you the one with the smaller number. So, say you have a fraction here and it has eighths. I don't know what its numerator is, but I know that it is equal to 21/56, right? So we can just try to do this, but backwards, right? We can say, okay, what did I multiply 8 with to get 56? I multiplied 8 with 7 to get 56. Well, what number do I multiply with 7 and get 21? The answer is I multiply 3 with 7 to get 21. So this equivalent fraction is 3/8. If you wanted the arrows to be pointing this way, it would have to be divide, but let's not get into that right now. You just saw how we work with equivalent fractions. Lastly, we have how to find the fraction of a number. So, for example, I want to find 3/7 of, let's say, 42, right? Now what this means is that I'm going to be dividing 42 into 7 equal teams, and then I'm going to take 3 of those 7 teams and find out how much is in that. Well, what that means is that basically I'm going to be doing 42 divided by 7, so divided by the denominator, right? And then whatever I find, since I'm taking 3 of these, I'm going to multiply this by 3, right? So I'm going to do 42 divided by 7 makes 6, and then multiply that by 3. 6 times 3 makes 18. Let's make this a little smaller so that we can do another example. Come on. Another example of this would be, let's say we need to find 2/9 of, let's say, 72. I take the big number, the number that's not in the fraction, right? 72. What I'm doing is I'm dividing it into 9 equal pieces. So 72 divided by 9. And then I'm taking whatever I find, and I'm taking 2 of these pieces, so times 2. 72 divided by 9 makes 8. Times 2 makes 16. And there we go. That's how we work with fractions like this. So that will be all for today. Tomorrow we'll be solving some more examples together. I will see you guys tomorrow. Bye.